Assalamu alaikum, miss.
Wa alaikum assalam. This is clear, right? Okay. I also need to share my screen today because I want you to look at the questions. Okay, so I like you'll have to keep you'll have to concentrate on two screens. Okay, one is my camera and the other is the screen that I'm sharing, because the questions are on the screen and my working will be here. Okay, my explanation will be in the camera. Okay, so it's 5:40. Let's get started. Is it recording? Right, it's recording, right? Okay. Okay, so let's get started. Yes. Okay, so first of all, what do you understand by moles? Okay, so I have already done this chapter, okay, in great detail. I explained each and every, in fact, I took separate classes for each and every topic of this chapter. Okay, the concept of mole, the concept of percentage yield, and all of that, whatever is discussed in this chapter. And so if you guys have any confusion regarding those concepts, I would recommend that you go and access those videos on our YouTube channel. But this class is only for these questions that were shared with me by a couple of students. And so maybe they will, this is a worksheet, I think, sort of given by the school. So I'm going to solve this worksheet. Okay, if you don't know, like while I'm solving, if you don't know what a mole is, or if you don't know anything that I'm discussing, you can raise your hand and you can ask, and I will try to explain briefly. But I would recommend you to watch those videos if there's any confusion. Okay, so let's get started. So let's get started with this first question. And now this first question is really old. It is 2000. Can you guys comfortably see the camera as well as the screen? Okay, how can how can I maximize this? No, how can I maximize this screen? I need your help. I want this camera to be maximized right now. Okay.
Yeah, we can.
Stop sharing. I'll have to stop sharing. No, but I do need to share.
So then just go here to see.
Okay, I cannot use both the screens together. Okay. Okay, so let's read the question first. Let's read the question first. Okay, the first question is, are you guys with me? I cannot hear any one of you.
Yes, miss.
Yes.
Okay, so this is the first question. Okay, a sample of impure copper was dissolved in, okay, before we start this, is everybody clear about mole? What's a mole?
It's a number of Avogadro's constant.
Yeah, what do you understand? Can you explain in simple words, like simple?
For example, if in 1 mole there will be 6.0 multiplied by 10 over 10 power 23 at atoms in that specific value. In that specific, like for example, if there is a box and we name it mole, so in that box, in each mole, there will be 6.0.
Right.
6.0 multiplied by 10.
Yes. I think you have the concept, but I just hope that others also have the concept. So basically, like for example, we cannot count the number of grains in a salt, right? If your mother tells you, okay, add 9 million grains of salt in that curry. Now that, I mean, how will you count 9 million? That will take ages, right? So it's easier to use an easier unit. For example, 2 spoons, just add 2 spoons of salt in that curry. So if we know how many millions are in 1 spoon, then it's easier, right? So then we know exactly how many grains did we add, because in chemistry, we need to know exactly how much chemical did we add in a reaction. So if, for example, 1 spoon has 1 million and the other spoon, for example, I'm just making, an assumption to explain you one, if for example, 1 spoon has 1 million grains and the other spoon has another million, so total are 2 million. Okay, but then million is a big number to deal with. You cannot all the time tackle and deal with such a big number, so it's easier to just say 2 spoons. So similarly, atoms are really, really small, and therefore their actual number is really big. The number of molecules or the number of atoms that participate in reactions is really big. So it is inconvenient to all the time mention the exact number of atoms or molecules that are participating. So it is easier to use the term mole. So think of mole as your spoon, okay? So 1 mole, for example, this is 1 spoon or mole. This has 6.02 into 10 to the power 23 particles. Also, pay attention to the word particle. Particle meaning that it can be atoms, molecules, ions, it can be anything depending upon what you're dealing with, right? If you're dealing with, if somebody says 2 moles of sodium ions, okay, if somebody says 2 moles of sodium ions, meaning two such groups of sodium ions, okay, and each group of particle will have 6.02 into 10 to the power 23. So this is 1 mole of sodium ion. This has actual 6.02 into 10 to the power 23 sodium ions. This is another mole. This has 6.02 into 10 to the power 23 sodium ions. Okay, so we don't say ions or atoms or molecules because we don't know which particle you're talking about. So we just use the term particle. Okay. Okay, so I hope you know this. Okay, so let's move on. Okay, so first question. A sample of impure copper was dissolved in nitric acid. The solution of copper 2 nitrate was filtered to remove solid impurities and evaporated to dryness. The solid nitrate was heated to constant mass to leave only copper 2 oxide. Okay, it is always a good idea to understand the question. What is the question saying? Then it'll be easier for you to calculate. So there's a metal reacting with acid, and we know whenever metal reacts with acid, we get copper 2 nitrate. Do I need to share the screen? You guys have this worksheet with you, right? If I just
Yes.
stop sharing, if I
Yes,
stop,
miss.
Yeah, that's fine.
yeah, you guys, yeah, all of you have it, right? So if I stop sharing, I think my video screen gets enlarged. Is it? Is it so?
Yes, but we can also like change whenever we want.
Oh, you can?
There,
No,
yeah,
miss,
there
I
is.
can't.
Okay, so you're comfortable if I share or if I don't share?
Yes,
Both
miss.
are okay.
Okay, ma'am.
Yeah, but the problem is I don't have this worksheet. So how will I read? That's the problem. But okay. Okay, right now I'm have to stop sharing because I need to explain this and I need to see if you can see this. So when the metal reacts with acid, you get the salt made and hydrogen is released. Okay, this is one of the properties of metal. When it reacts with acid, it releases hydrogen gas, and this is the salt. And so they are trying to calculate the purity, I think the percentage purity of copper. And so copper, this is impure copper, okay, and then they filtered it. So solid impurities are on the filter paper, but if there are any other liquid or dissolved impurities, of course they will also come out through the filter paper. And so the filtrate is copper nitrate solution. They are heating it, okay, due to heating, it is decomposing. Decomposition is breaking of a compound into simpler compounds. So copper oxide, nitrogen dioxide, and oxygen gas. Now their question is, and I cannot even minimize it, I need to share the screen to be able to read the question. Okay, so their first question is, complete the following to determine the percentage purity of the sample of copper. The mass of 1 mole of copper oxide is 80 grams. Okay, now the good thing about the questions these days of IGCSE is that they have really simplified the question. Like, you know, they literally hold your finger and walk you through the question to the final answer. So the first step that you have to do is to calculate the number of moles of copper oxide. And I also recommend, please keep your eyes on the question. I want you to look at the question. Okay, then mass of 1 mole of copper oxide is 80 grams. So that's the molecular mass. Okay, and they want you to calculate the number of moles of copper oxide. So what is the formula for the number of moles? How do you calculate the number of moles?
Mass of
Molar mass.
Yes, mass divided by the molecular mass, right? Molecular mass is also called molar mass. Why is it so? Why is the molecular mass the same as the molar mass? Any idea? Okay, because you see, they have arranged the atomic masses in such a way that if you convert the molecular mass into a molar mass, you will get the exact same figure. The only difference would be in the units. So molecular or the atomic masses don't have a unit because they are ratios, but in molar mass, you get the molar mass, the unit is grams. Okay, so mass divided by the molecular mass. So you can now shift onto my screen. I'm explaining here in the video. So mass according to the question, mass of copper, this is the number of moles of copper oxide. Okay, so mass of copper oxide according to the question given in the question is 4.8 grams. So I plugged in 4.8 grams and I divided it by the molecular mass, which is 80. Okay, and how did I get 80? 80 is already given. You know, these questions are so easy. They have even given you the molecular mass themselves. They don't want you to calculate. They have given you the molecular mass of copper oxide, which is 80. You just simply, with the calculator, you divide 4.8 by 80 and you will get 0.06. So that is the answer. This is the number of moles of copper oxide. Okay, now what is the mass? That's easy. So now who will tell me, how can I calculate the mass of copper oxide? Yes. Who can
mass will be equals to number of moles multiplied by
very
number
good.
of moles multiplied by
Assalamualaikum, miss.
the relative formula mass.
Right. So the mass would be the number of moles multiplied by the molecular mass of copper. So number of moles of copper we calculated in part 1 to be 0.06. We multiplied that by the molecular mass of copper, which is also given in the, no, it's not given in the question. Okay, so you can look
It's 64.
yeah, you can look at the periodic table. So keep a periodic table with you while you are solving these questions in case they have not given, but mostly they have. Okay, so 0.06 multiplied by 64, use a calculator and you get the answer. Okay, 3.84 grams. So that is the mass of copper. Yes, Zainab?
Miss, I just joined. Which part are we doing in question 1?
We have calculated the mass of copper. I think so did you have any question in this? Did you have any confusion in this question?
No, miss, I just raised my hand so to know at which part we are. Because I just joined.
Okay, are you the same Zainab who shared the past papers in the group?
Yes, miss.
Okay, good.
Something wrong with it, miss?
Sorry?
Is there something wrong with the past papers? Like,
No. I did not get time to check, but I don't think so. Okay, so mass of copper, so where were we? So number of moles of copper oxide.
The
Miss,
percentage of copper.
Yes.
Miss, can you show the other part again? The
Okay,
mass
so
of copper oxide.
okay, so this is then okay, I'm going to repeat, just I will just recap. So we calculated the number of moles of copper oxide. How did we do that? We divided the mass by the molecular mass, so we got the number of moles of copper oxide. Okay, so what is the mass of copper oxide? Mass of copper oxide would be, wait, mass of copper in copper 2 oxide. Mass of copper in copper 2 oxide. Yes. Okay. So we have to calculate so the mass of copper is the number of moles multiplied by the molecular mass. Okay. So why is the number of moles copper also 0.06? The number of moles for copper in copper oxide is also going to stay 0.06. Why? 0.06 moles of copper oxide. But here we are calculating the mass of copper. Why are we using the same number of moles? Any idea?
Yes, miss.
Yes?
Miss, because in the equation they are like the coefficients are 1, so 1:1. That's why.
Right, very good. Because 1 mole of copper oxide is going to have 1 copper.
Yes, miss.
Yeah, 1 mole of copper oxide will have 1 mole of copper. Okay, remember the numbers that you see in the equations are the number of moles. Okay, they are not the number of they are not the exact numbers of particles present, but they are the number of moles. Okay, so because the equation shows us that copper is going to be if for example this was like this, if it was this way, if the formula was this, okay, then this would be changed. Now if the number of moles of copper oxide is 0.06, the number of moles for copper would be twice. So I will multiply it. I would then multiply 0.06 by 2, and that would give me the number of moles of copper. But this is not the case. Here it is simple. 1 mole has 1 mole of copper. The ratio is 1:1. So I will use the same number of moles for calculating the mass of copper. So I used 0.06, which represents the number of moles of copper. And I'll multiply that by the molecular mass of copper, which is 64. You can see my working, right? And so when I multiply them, I get 3.84 mass of copper. This is the mass of pure copper. This is the mass of pure copper. And I can even write it here, mass of pure copper. How do I know that this is pure copper? How do I know? Because you see, there is no other product containing copper. This is the only compound that has copper. And if I know its number of moles and its exact number of moles, I can easily find out the number of moles of pure copper, which is forming a part of it. And using those number of moles, I can calculate its mass. So that's how I know that this is the mass of pure copper. Now, we have to calculate the percentage of copper, percentage purity. So we know the formula, right? Percentage means out of 100, right? So I can use the ratio. I can show you the ratio method. Let's do it the ratio method. If impure copper, whatever for example, X grams of impure copper has Y grams of pure, X grams of pure copper in Y grams of impure copper, then how many grams of pure copper in 100? How many grams of pure copper in out of 100? You know, this is the ratio method. I don't know how you guys do ratio method. We use equivalent fraction. I make use of this. So percentage of copper, or you can just simply learn the formula: mass of copper divided by the total mass of impure copper, which is the same as, let me do it, my ratio method. So impure copper. So we can say impure copper, according to the question, is 4.21. So 4.21 grams of impure copper has 3.84 grams, right? 3.84 grams is what we calculated. So 100 would have how much? I will cross multiply 3.84 by 100 and then divide by 4.21. Okay, and I will get 91.2%. Okay, they have converted this into a formula. So this is pure copper divided by the impure copper multiplied by 100. Okay, so mass of pure substance divided by the mass of the impure substance, total substance, total means including the impurities, and you multiply that by 100 and you will get the percentage. Okay, so this is the percentage of copper
Miss?
which was pure. Yes?
Miss, how did you know that 3.84 is pure copper?
Beta, I just remember this calculation. Did you understand this? How did I get this? Did you understand this part?
Yes, Miss.
Okay, so now this is the mass of copper in copper oxide. There is no other compound which contains copper. So if I can exactly find out the number of moles of copper oxide, I then automatically know the number of moles of copper. 1 mole of copper oxide will have 1 mole of copper, right? And so using that number of moles I calculated, I multiplied it by its molecular mass. I calculated the mass of pure copper. So I know that in this sample, this much is pure copper. There are 3.84 grams of pure copper. So if I want to find out the percentage purity, I will divide this by the total amount, meaning including the impurities, which is 4.21 grams. And this formula is given in your book as well. Mass of the pure substance divided by the mass of impure substance multiplied by 100 is percentage purity. Okay, and so that's how I calculated. Did you understand, Yusra?
Yes, Miss. I also want to ask you another question, that how is 80 gram molar mass?
Oh, molar mass is the same as the relative formula mass. So they have just added the values from the periodic table. So copper is 64, oxygen is 60. You add 64 and 16, you will get 80.
Okay, Miss. Okay. Thank you.
Okay. Have you guys done this with your teachers, school teachers in the class?
No, Miss.
No, miss.
Miss, this is a past paper. It's all compiled together. She gave it for practice.
Okay. So have you guys done the questions in the book?
Yes, miss.
Yes? Okay.
Yes, miss. And miss, for the first term exams, we don't have percentage yield and percentage purity. In syllabus, they didn't give in study guide.
Okay. So see, that's the thing. That's the thing, you know. That's why I recommend you guys, I recommend that you guys go ahead and use that website that the link of which I shared in the group. They have compiled the questions topic wise. And so, you know, it's easier, and they have the answer key also there. So did you understand then? If you haven't done percentage purity, then I don't know if you understood this.
Miss, I got it. Like,
No,
I
miss,
got
we
the way
did
you
this.
found it.
Yeah.
Although we didn't do it, but I got this, how you did it.
Okay, good. Alhamdulillah. Okay, let's move on. So have you done the number of moles of gas? Have you done the next
Yes.
part 2?
Yes.
Miss.
Yes, miss.
Okay,
Yes.
okay.
Yes,
So
miss.
then recap, a real quick recap. How do we calculate the number of moles of gases? Real short, one sentence. Okay, what is the yes? Yes.
Volume divided by molar
Volume
mass.
divided by molar volume.
Volume divided by the molar volume. Yeah, okay. Yes. Yes, yeah, that we can calculate the number of moles that way.
And the molar volume is 24 decimeter cube for all the gases.
Yes, at a standard room temperature and pressure. At room temperature and pressure. Okay. So let's calculate the volume of gas formed at room temperature and pressure, which is the second part. So looking at the equation, how many moles of gases do we have? Now we know nitrogen dioxide is a gas, oxygen is a gas. So total moles is 4 from here and 1 from here. 4 nitrogen dioxide and 1 mole of oxygen, total mole. Because you see, the question is asking volume of gas. They did not name the gas. Okay, so I presume that we have to combine, okay, the total volume of gas. They're asking total volume of gas. So that includes both, right? So I will take 4 plus 1, 5. So now we know the number of moles of copper oxide, right, from the first part. So we will make use of that. We will make use. And remember, whenever they give you parts, their answer should be used, in the latter parts. So the number of moles of copper oxide is, so the ratio, first of all, let's look at the ratio. 2:5. For every 2 moles of copper oxide, we are getting 5 moles of gases produced. Is that right? For every 2 moles of copper oxide being produced, there are 5 moles of gases being produced. So the ratio of copper oxide to gas is 2:5. So if the number, so we will make use of this ratio. If the number of moles of copper oxide is 0.06 moles, how many moles of gas? 0.06 multiplied by 5 divided by 2. Okay, and I get 0.15 moles of gases. Now this is combined. This is both combined, nitrogen dioxide and oxygen. 0.15 moles of these gases. So what is the volume of gas? Simple. If what I do is 1 mole has a volume of 24 dm cube. Can you see my working? 1 mole has a volume of 24 dm cube. Then 0.15 moles will have how much volume? So multiply 0.15 multiplied by 24. 0.15 multiplied by 24. And I get this. Okay, so this is the volume of gas being produced. Yes?
Miss, I don't get the way, like, how is it 5 ratio? Can't we just do 2:4 ratio 1?
So they are asking you the total volume of gas. They're asking you the total volume of gas. So even if you take 2:4:1, first of all, it will make your calculation complicated. Secondly, it will give you separate. I don't know if, yeah, it will give you separate number of moles and everything.
And Miss, when the copper moles are like they're 2 copper oxide, so shouldn't it be 2 times 0.06?
Who is this?
Me, Miss Zainab.
Oh, okay. You know what? You gave me a good idea. Let's do it separately and see if we are getting the same answer. Okay, let's do it. So let's first find out the number of moles of nitrogen dioxide. Maybe, you are right and maybe we should do it separately. Let's see, or maybe we'll get the same answer. I don't know. So let's do it. So,
Okay, Miss.
okay, 2:4 is the ratio. So copper oxide moles is 0.06. So now get hold of your calculators.
Miss,
0.06
it should be 0.012. I mean 0.12
0.2
instead of 0.06.
divided by 2 is 0.12 moles of nitrogen dioxide. Okay. And then we have 2:1. So 0.06 divided by 2 would be 0.03 moles of oxygen. So total moles will be 0.12 plus 0.03 is 0.15. Yes, same thing.
Miss,
Here we're getting 0.15 moles, and here also we got 0.15 moles. Did you see? Here also we got 1.15 moles. So if the number of moles is the same, you multiply this by 24, you'll get the same volume of gas. Yes?
Miss,
Yes, so you can do it separately if you want, and you can, just combine them. Doesn't matter.
Miss, when it's telling us to find the number of moles of the gas, then why are we using copper oxide since it is a solid?
Sorry, they are asking about gases, and so why are we using copper oxide? Is that your question?
Yes.
See, even though the states are different, they are the products of the same reaction, right? They are the products of the same reaction. So what I'm doing is that I'm making use of this ratio. So if I know the number of moles of one product, I can use this ratio to find out the number of moles of other products. I'm just using the ratio, that's all. So that doesn't matter if the products are in different states of matter. But yes, for gases, you will have to use a different formula. I mean, if there's a different method of finding the number of moles of gases and the number of moles of solid, the method is different, but we can use the same ratio. Did you understand? Yusra, is there?
Yes, Miss.
Yeah. Is there any other question? Because I'm sharing my screen, I cannot see. Yeah. Okay, Zainab, you have your hand raised. Do you want to ask something?
yes, miss. Miss, you wrote 2:4. So, but in the above part, we calculated 0.06 for just one copper oxide. So shouldn't you multiply 0.06 by 2 so that you get 2 moles of copper oxide instead of 1?
I didn't understand your question. What do you mean? I mean, can you repeat your question? This is, the ratio of copper oxide to nitrogen dioxide is 2:4. So you wanted to do them separately, right? So I used the ratio separately. 2:4. So I use 2 because I know the number of moles of copper oxide. That's why I'm using copper oxide. Okay, so 2:4. So what was your question again?
Miss, under 2 you wrote 0.06, which is just for one copper oxide mole. Just for one mole of copper oxide.
No, no,
But
no, no.
over there in the equation, it's
No.
2 written. So shouldn't you multiply it by 2? 0.06?
Beta, this is the actual number of moles of copper oxide. Okay, and this is the ratio. This is not the exact number. These numbers that you see in the equation, they are not exact numbers. They are ratios, simplified versions, simplified ratio. Do you understand what is the difference between actual numbers and ratios? Do you understand the difference?
Yes, miss.
What is it? For example, I have 10 moles of A and I have 20 moles of B. The ratio is, what is the ratio? To find out the ratio, the easiest method is to divide both the numbers by the smaller one of them. Smaller one is 10. Okay, can you please wait? Can you please excuse me? Wait.
Miss, I can't hear you.
Okay, sorry. Yes. So if, for example, I have 10 moles of A and I have 20 moles of B, how can I find out the exact ratio? I will divide both of them by the smaller one of them. Okay, this is the easiest method of finding out the ratio. So I get 1 and I get 2. So 1:2 is the ratio. Ratio is to find out, like, you know, the smallest numbers, what in, I don't know how to explain this. Ratio is, you know, like,
Miss, you don't get my question. Like, what if there's a 2 on the left side of A?
wait, what if there is 2 on the left side of
A. The A you did right now.
yes, okay,
What if there's the 2 at the left side of the A? Like a coefficient 2.
yes, okay. So no, right now the coefficient of 2 is with B. Okay,
Yeah, what if the
so
Miss, what if there's an equation
yes, this has
A
to,
plus
if this has to, then it would be this way. Then the numbers, the actual numbers would be this way.
yes,
This
Miss.
is 2:1. Yes.
So the same thing is that over there with copper there's a 2, but you are like doing it for just fun.
I see, this is 2:4, right? For every 2 moles of copper oxide, you are getting 4 moles of nitrogen dioxide. For every 2 moles of copper oxide, you're getting 4 moles of nitrogen dioxide. So if you have the exact number of moles of copper oxide is 0.06, for 0.06 moles of copper oxide, how many moles of nitrogen dioxide will you get? Okay, so what I did is I cross multiplied 0.06 multiplied by 4. I got 0.24 and I divided that by 2. Zainab, are you still confused?
Miss, you remember when you placed a 2 with A, you doubled the 10. You multiplied by 2. 2 times 10, isn't it? And then you find its simplest form.
But listen, beta, that was an example and I can change the numbers here. In the question, they have already given me these numbers. I cannot change them by myself. I cannot do that. Okay, I have to go with the numbers that they have given me. Do you understand? So this 0.06 moles is the number of moles that I calculated from part one using the information that they gave me in part 1. Okay,
These number of moles, isn't it for just for one compound of copper?
you are trying to ask that this number is for only one compound? Is that?
Yes, ma'am.
Yeah.
Yes, miss. Instead of, but in the equation it's 2.
Yes.
So shouldn't you multiply it by 2 then?
You know what? You are not getting the idea. This is, what is this? What is this? Tell me, what is this? 0.06.
Mole of copper oxide. 1 mole of copper oxide for just
बेटा
one
1 क्यों कह
compound,
रही हो आप?
isn't it?
आप इसको 1 क्यों कह रही हो? This is not 1. This is the number of moles.
Because miss, on the upper side when you calculated the number of moles of copper oxide formed, it was just for one copper oxide, isn't it? Not for 2.
I never calculated the mass of copper oxide. Okay.
Moles of copper oxide, miss. Moles.
Yes. So moles. So there are 0.06 moles of copper oxide. You know what? 1 minute. I get your confusion. You are thinking that this 0.06 is belonging to one copper oxide. And this is 1. And so because this is 2, I should multiply this by 2.
Yes, miss. Yeah, that's what I'm asking.
Okay, for the time being, get out of that thinking. Leave it. Okay, leave your thinking. Now come with me. Think like I want you to think. Okay.
Okay.
Okay, what you have to do is, this does not belong to 1. Okay, there are 0.06 copper oxide. This is not 1, this is 0.06. Understand this. This is 0.06 moles of copper oxide. Okay, this is the actual number of moles, but the ratio in which the moles exist of copper oxide 2 nitrogen dioxide is 2:4. For every 2, you have 4 nitrogen oxide. For every 2, you have 4 nitrogen oxide. So for
Got it, miss.
so for
I understood.
yes, so for 0.06 moles of copper oxide, how much do you get? So simple ratio method we have used. Okay.
Yes, miss, I got it. You told me that there should be 0.06 moles of copper oxide, not 1 or 2.
Yes.
So that's why we did it. Yeah, that's
Yes,
what.
very good. Yes, and
Got
1
it.
or 2, and another thing, 1 or 2 are only ratios. They only tell us that, you know, for each 1 molecule, how many will react. For each 2, how many will react, or whatever the number is. Okay. Okay, good. But it is a good thing.
Got it.
Yeah, if you are confused, please do ask this way. It's okay. Okay, even if we are in the middle of the class or I'm in the middle of the explanation, I mean, do wait for me to finish the question, but then do ask whatever your confusions are. Okay, so so you understood, right, how we calculated the number of moles of gases, 0.15.
Yes,
And
miss.
yeah, multiply that by 24 and we get the volume of gas. Okay, now next question. Next question is, you guys have the worksheet. So the following is part of the description of the preparation of the soluble salt lithium chloride. Okay, 25 cm cube of a solution of lithium hydroxide concentration. Okay, my question for you guys, do questions like these terrify you? Like when you read all these stories, you know, 25 cm cube of a solution of lithium hydroxide, concentration of this was placed in a beaker. Do you know
Yes.
what?
Yes,
Yes,
miss.
miss.
So what's
It
happening
feels
here?
like it's sticky.
So what's happening here? If you understand the story, it won't scare you. So I want you to understand what's happening here. 25 cm cube of a solution of lithium hydroxide, concentration this, was placed in a beaker. What is a hydroxide? What is a hydroxide? What sort of a solution is a hydroxide?
Alkali.
Very good. Yes, very good. Yes, it's an alkali. Very good. Yes. The concentration is 1 mole per dm cube. And don't be confused. Don't be terrified. 1 mole per dm cube means what? 1 dm cube has 1 mole of lithium hydroxide. That's what it means. 1 dm cube has 1 mole of lithium hydroxide in it. So we have a solution. If you are terrified, make a diagram. Visualize it. So I have 25 cm cube. The total volume is 25 cm cube of lithium hydroxide. Okay, 1 dm cube has 1 mole. Okay, this is my lithium hydroxide. Okay, now this must be a neutralization reaction. A few drops of the indicator methyl orange. Now, what is an indicator? This is methyl orange. What is an indicator? Yes.
It tells the pH of the solution.
Yes, it tells the pH of the solution and it changes color so that we can visibly, easily see when the neutralization reaction has been completed. So because it will change its color right when the alkali has been exactly neutralized by the acid. Okay, so looking at the equation, lithium hydroxide is reacting with hydrochloric acid in this. And so they have given the equation in the worksheet, and the equation is something like this: lithium chloride and water. So this is simple neutralization reaction. Alkali reacting with acid, giving us salt and water. We are using indicators so that we can find out when exactly has the alkali been neutralized by the acid. Okay, so a few drops of indicator have been added. Okay, and the mixture turned yellow because methyl orange is yellow in color in the alkaline solution. So because this is an alkaline solution, when we add methyl orange, it turns yellow. Then we add hydrochloric acid through a burette. Okay, and why are we using burette? Why are we using burette? Can anybody tell me? Why can't we just simply add? Why are we
Because
using? Yes.
because
To
we
measure
need
the
to.
exact number of volume.
Yes, Sarah, was that you? Yes, Sarah.
Because we need to find the exact volume that we are adding.
Right, exactly. Very good. Yes. So that we know what volume of acid did we add, what volume of acid neutralized this alkali exactly. So that is why. Okay. So we are using burette until the mixture just turned red. So according to the question, when the mixture turns red, that's when the reaction has been exactly complete. 20 cm cube of the acid was needed to neutralize the alkali. That means 20 cm cube was just enough to complete the reaction. Now, why am I saying exactly? Why am I saying just enough? Because by mistake, you can add more than what is needed, right? That, I mean, human error is always possible. But I need to know what is the exact point. I don't want to miss that point. Now, according to this equation, the ratio is 1 is to 1 is to 1 is to 1. All are 1, all are equal. So their moles are reacting and being produced in equal ratios, right? So appreciate that. Now, so this is the story, okay? This is the story given in the question. So don't be afraid. This is just a neutralization reaction. This is the alkali. They are adding acid. They have given the volume here. They've given the concentration and the volume. Okay. Now this is easy. If 1 dm cube has 1 mole, then how many moles will be in 25 cm cube? Simple ratio method. Okay. By the way, people use formula. You can use formula too. You must have noticed I don't use formulae because I tend to forget them. So I stick to my ratio method. Same thing. They got the formula from the ratios. Same thing. So if it's easier for you to learn the formula, go ahead and use the formula, but you'll get the same answer. So number of moles of lithium hydroxide is so easy. How many cm cube in 1 dm cube? And why am I converting?
20.
How many cm cube in 1 dm cube?
1000.
Very good. Very good. Yes, 1 dm cube has 1000 cm cube. So you can either convert this into dm, okay, or you can convert this into cm. Both ways you'll get the same answer. But remember, the units should be the same. Whatever you use, they should be the same for your answer to be correct. Okay, so 1000 cm cube has how many moles? 1 mole. 1 mole per dm cube. 1 dm cube is 1000 cm cube. That means 1 mole in 1000 cm cube. Okay, and 25 cm cube will have how much? So again, ratio method. Okay, 25 divided by 1000. I get 0.025 moles of lithium hydroxide. Okay, so this is part 1. Is everybody with me? Did you understand?
Yes, miss.
Yes.
Okay, now what are the number of moles of HCl, hydrochloric acid? Now can you see the ratio is 1:1? That means they are equal.
Same.
Yes. So that means the number of moles of HCl are also 0.025 moles. Same. Okay. And these 0.025 moles were present in this burette, right? In this 20 cm cube. Remember, the question mentioned that 20 cm cube is the exact volume which is required to complete this reaction. That means these moles are present in 20 cm cube. So if 20 cm cube have, yes, 0.025 moles, then 1000 cm cube will have how many moles? Because they are asking us to find out the concentration. What is concentration? Who will define concentration for me?
The amount
The
of
amount
solute
of
added in the
solute in
solvent.
a solvent.
Molar concentration. I want molar concentration. So raise your hand and I will unmute you. And you can unmute yourself. Yes, raise your hand. Molar concentration definition. Come on. Yusra, molar concentration. Ahmad, Ahad. Have you done this with the school? With the teacher?
No, miss.
No, you have not done molar concentration.
Yes, we have.
Then beta, why are you worrying about these questions? They will not ask you these questions then. Then why did you guys ask me to solve these questions?
Miss, these are there. Even in the study guide, they asked us.
Molar concentration is included?
Yes, miss.
Okay, so then tell me, what is molar concentration? Nikalo, book nikalo.
Moles over molar volume. No, moles over volume.
Yes, okay, good. Number of moles per unit volume of solution, right?
Yes.
Yes. So we have two concentrations. We have two types of concentrations, and I did this in my classes. This is the mass concentration, in which we divide the amount of solute divided by the volume of solution. But the molar concentration is the number of moles divided by the volume of solution. Okay, they did not give in the form of formula, but they have mentioned it here. These are the two differences. Mass concentration is measured in grams per cubic decimeter. So that means amount of solute per unit volume of solution, which is dm cube. So you can say amount of solute per dm cube of solution. Whereas molar concentration is the number of moles of solute per cubic decimeter of the solution. So number of moles in 1 dm cube, that is molar concentration. Number of moles per dm cube, and 1 dm cube I know is 1000 cm cube. Well, you can convert this into dm and then use dm. That is also fine. Okay, but I'm using this. So if I multiply 1000 by 0.025, I will get 25 divided by 20, which gives us how much? 25 divided by 20 is 1.25 moles per dm cube is the concentration of this acid, HCl, okay, which we used to neutralize. Is everybody clear? Is there any question?
Miss, can
No,
you please
miss.
repeat to understand what you did?
Which part you didn't
Yes, miss,
understand?
about the
For the
concentration
concentration
of
of
HCl.
HCl.
Yes, Yusra, what? Which part you didn't understand?
For the concentration of HCl.
Okay, so did you understand the number of moles of HCl? Did you understand how we got the number of moles of HCl?
Yes,
Yusra?
miss.
Yes.
Yes.
How did we get? We calculated the number of moles of lithium hydroxide. Okay, that was 0.025. From the equation, we know that the ratio of lithium hydroxide to acid is 1:1. Okay, and so if 1:1, meaning that they are equal. Okay, the same number of moles. So if lithium hydroxide is 0.025 moles, hydrochloric acid would also going to be 0.025 moles. Okay. Now, these number of moles are required to complete this reaction. And in the question, they mentioned that they needed 20 cm cube of HCl to complete the reaction. That means 20 cm cube has all these moles that are required for the reaction. Okay. And so 20 cm cube has 0.025 moles. They are asking us concentration, right? Concentration is to find out the number of moles in 1 dm cube or 1000 cm cube. So I just use the ratio method that if 20 cm cube have 0.025 moles, 1000 cm cube will have, I multiplied and I divided. Is my ratio method confusing you guys?
Miss, what if we use formula over here?
Yes, 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 please use the formula, same thing. So, okay, let's use the formula. Molar concentration is number of moles divided by the volume of solution, right?
Yes, miss.
Yes. So
Yes,
number of moles is एक minute. Okay, so now here you will use dm. Okay, I was using cm, you will use dm. So number of moles is 0.025 over volume of solution is 0.02. So what do you get? I don't have the calculator. Please somebody do it for me. Where's the calculator?
Miss, the same answer, 1.25
Yes, so 1.25
moles per decimeter
yes.
cube.
Okay, but if you are using this formula, remember your formula, your volume should be in dm cube. Okay, your volume should be in dm cube because the answer they want is in mole per dm cube. Okay.
Okay, miss. Miss, what if they ask us to answer in grams per?
Okay, grams. Okay, then you will have to multiply these number of moles by the molecular mass. You will get the mass in grams. Then you will multiply the number of moles by the molecular mass of HCl. Okay, whatever that is, when you will multiply, you will get the mass. And so mass divided by the same volume will give you the concentration in grams per dm cube. Okay.
Volume will not change. We'll not multiply volume with the MR.
No, beta. No. The volume is of the solution. Remember, per dm cube.
Yes,
So,
miss.
yes, so per dm cube of the solution. So this volume will stay the same. No.
Oh, okay, miss. Got it. We have to convert moles when we need to have grams per decimeter cube.
Beta, see, you have to understand the concept. The mass concentration is what? Mass concentration is the mass of the solute. Let me write it somewhere. Mass concentration is the mass of solute. Mass of solute divided by the volume of solution. This is the formula, right? This is the mass concentration. So mass of solute in this particular case is the mass of HCl. It is the mass of HCl divided by the volume of solution. The volume of solution will stay the same, which is 0.02. Yes, which is
Okay, miss.
0.02. Yes. So this mass you will calculate by multiplying the number of moles by its molecular mass and then dividing that by 0.02, you will get the a concentration in grams per dm cube. Okay.
Okay, miss.
Okay.
Miss,
Yes.
Miss, can you solve the number of moles for lithium hydroxide by using the formula?
Okay. Number of moles of lithium hydroxide. So what is the number of moles formula?
Number of moles equals to mass over relative formula mass, MR.
Yes, but in this case, we are using the molar concentration.
Concentration to volume.
Yeah, so we will use the formula of molar concentration because in the question they have given us molar concentration. Molar concentration is, this is the formula, I'm writing down the formula. Number of moles of solute divided by the volume of solution. Okay, so number of moles of solute, we don't know, we have to find. I'm giving it X. Volume of solution is 25, but I will now convert it into dm. I will convert it into dm. So 25 cm cube, I will divide that by 1000. I'm going to get 0.025. Okay, molar concentration according to the question is 1. Okay, it's 1 mole per dm cube. So yeah, I cross multiply. Number of moles is 0.025 moles of lithium hydroxide. Okay.
Yes, miss.
Yes. Okay. Okay, then, I mean, it is easier to remember these formulae if you know the concept behind it. Don't just simply memorize the formula, because then if they trick you, you will get tricked easily. But they're not tricking. I can see that the questions are really simple. Okay, let's do just one more question and then we are out of time. And this question is really lengthy. By the way, this question
Miss,
is
for that question that we did right now, how did you know that it was molar concentration and not just concentration?
because we have only two types of concentration. We have molar or mass. So look, do you have the question in front of you? Do you have the
Yes,
question?
I have printed.
Yes, okay. So take out that page. I think this is page 3. Okay. So look at the concentration of lithium hydroxide. What have they mentioned? 1 mole per dm cube. So they have given you number of moles per dm cube. They have not given you a grams per dm cube. If they had given you grams per dm cube, then it would be mass concentration. But this is number of moles per dm cube. So this is molar concentration. Did you understand?
Yes, miss. Yes.
Okay. Did you understand? Okay. If you guys have not done molar concentration with your teacher and with your school, and you have not even heard my videos, then it's very difficult. I mean, I don't think you guys are understanding. Are you guys understanding?
Miss, I have seen